I know about these subjects. First, we learn the basics of electric fields. There are two charge, which is positive charge and negative charge. For same charge, either positive or negative, it will repel. And for different charge, it will attract to each other. So this is the electric field line, which is, this is the positive and this is a negative. Positive, it will away from the, it will move away, and while negative charge, it will direct towards to the charge. So the units of the electric field is a coulombs, or symbols C, and the value of C is 1.6 times 10 the power of negative 19. So this is a few example, which is we can assume this is a positive charge and this is a negative charge, where the positive charge will attract and move to the negative charge. And the second is if we put the positive charge besides positive and positive, it will repel, so that the charge, the direction line, it will away and separate. For the third example, we can assume this is a positive and the other side is a negative. So the positive charge will attract and move to the negative charge. And for the example 4, we have this is the negative plate, and the charge positive will move to the negative charge that has in plate. Okay, here this is current SI, and potential difference as a V. So the definition of the rates, the definition of currents of I, symbols of I, is a rate of flow of charge. From the definition, we can get the formula as a Q per T. Q is a charge and T is time. So Q over time, charge over time. And the SI unit is a ampere or A. The apparatus we use to measure the potential, to measure the current, is a ammeter. Okay, this from this sides, this is the potential difference. So the definition of potential difference is a work done to move a unit charge between 2 points in an electric field. The formula is W over Q. So the W stands for work and Q stands for charge. So the unit is volt. And the apparatus we use to measure the potential difference is a voltmeter. So what the relationship between current and potential difference? Let's imagine if we have one container where A and B, the water level of A is higher than the water level of B. From this, we can be like this: A and B, and the water level will be equal. Okay. Same goes to the wire. In here we put A, label as A, and this is a B. If A high potential, if we assume as A is a high potential and B is a lower potential, so it's same as example we learn here. The potential, high potential and lower potential, it will become like this: high potential, and it will be same, equal. So here is the high water level difference. The rates of water flow also high. So okay, let me write here the water level difference. Okay, the higher water level difference, the higher rate of water flow. Okay. Okay, we can assume this is as a V and this is as a I for current, and it's a potential difference. So from this, V is proportional to the I. If V high, if the voltage high, the current will be high, while V, the voltage low and the current will be low.